Hello, smart learners. You're welcome to Maths Mind with Ijeoma. Imagine you're given such problem. Will you just go ahead to multiply 2 according to the power and multiply the second one according to the power before multiplying to get your result? No. And that brings us to today's topic, indices. Indices, as the name implies, power. It means power, exponent. And somebody will be wondering what index is. Indices. Index is a singular and indices is the plural. When you have just one power, like 2 raised to power 3, that means you have an index number. But if you have such number, 2 raised to power 3 times 2 raised to power 2, the powers are now more than 1. So it's called indices. And we have 6 laws of indices, 6 basic laws. The first is multiplication law. The second is division law. The third is zero index law. Zero index law. The fourth is negative index law. Negative index law. The next is fractional index law. And the last one, power of power law. Now, we'll be talking about these laws one after the other. In multiplication law, you must have same base, likewise division law. So you can have a raised power x times a raised power y. In division law, you have a raised power x divided by a raised power y. Or you can see it as a power x over a power y. Is still division law. Okay, zero index law. You can see a raised to power 0. Negative index law. You can see a raised to power minus 1 or any other power but negative. Fractional index law. You can see things like a raised to power 2 over 3. Okay, let's use alphabet x over y. And power of power law. You can see things like a raised power x or power y. Okay? So, in indices, you have every operation that has to do with powers. If you watch all we have here, it is related to one power problem or the other. Now, let's solve some examples on them. Multiplication law. We can have 5 raised to power 2 times 5 raised to power 3. What do you do in this case? Just go ahead and pick 5 raised to power 2 plus 3. Plus because it's multiplication. Multiplication is related to addition. That is why they are always going in line, because multiplication is like a repeated addition. Okay? So, if you have such thing, you will be having 5 raised to power 2 plus 3, 5. 5 raised to power 5. You can now choose to sort out your answer. 5 times 5 times 5 times 5 into 5 places. That will be your final answer. Coming to division law, you can have 5 raised to power 4 divided by 5 raised to power 3. In this situation, like you did here, the difference is picking 5 and subtracting the powers. So you have minus. because division is like a repeated subtraction. Like saying 15 divided by 3 means subtract 3 from 15 until nothing is remaining. 15 minus 3, 12, minus 3, 9, minus 3, 6, minus 3, 3, minus 3, 0. I subtracted 5 times to make it 0. That means repeated subtraction gave me my answer 5. And in actual sense, 15 divided by 3 is 5. You have 5 raised to power 4 minus 3, 1. Okay? Coming to the next law, zero index law. Zero index law. Let's number it so that we won't be mistaking anything. Zero index law. You might have 3 raised to power 0. In this situation, anything raised to power 0 is 1. That is why in mathematics generally, anything you raise to power 0 is 1. Even alphabets, it will surprise you to know that x raised to power 0 is also 1. So this is 1, this is 1. So anything at all raised to power 0 is 1. It is a law gotten from indices, but it applies to mathematics in general. Coming to the next one, we have negative index law. As the name implies, negative, minus. We have things like 3 raised to power minus 2. Let's do minus 1 first. 3 raised to power minus 1. And whenever you see negative index, just know that it is 1 over. So this will give us 1 over 3 raised to power 1, which is the same as saying 1 over 3. Let's use another number for the negative index law. So we have 2 raised to power minus 3. If you have something, what do? Just put your 1 over 2 raised to power 3, which is like saying 1 over 2 times 2 times 2 into 3 places, which is 2 times 2, 4, times 2, 8. So this is 1 over 8. Let me clean so that we'll have space. The next is fractional index law. That's the 5th law. In fractional index law, as the name implies, fraction, it has a numerator and a denominator. Let's have an example. 16 raised to power 1 over 2. 16 raised to power 1 over 2. When you have such case, just know that numerator becomes power and denominator becomes root. Numerator becomes power, denominator becomes root. Okay, so we'll be having square root of 16. Why am I not putting root 2 here? Because square root itself is root 2. Okay, so we have power 1. Square root of 16 is 4. Square root means what number will you multiply by itself to give you the given number? Squares and square roots, they are still under powers. Whenever you talk about square, it is the result you get when you multiply a number by itself. Why the square root is that number that you will multiply by itself to give the given number. 10 square is 100. Square root of 100 is 10. 10 square you multiply it by itself to give you the square, 100. Square root of 100. Which number do you multiply by itself to give you 100? And it's 10. How is it gotten? Let's just break it down. 100. What can go? Let's use 2. Whatever number that ends in 0, 2, 4, 6, and 8, 2 can divide it first. So let's go. 2 can divide 100. 2 in 10, 5. 2 in 0, 0. 50. It's also ended in 0, so 2 can go. 2 in 5. 2 times remainder 1. 2 divide 10. That 1, remainder 1, you add it to the next number. So 2 divide 10 is 5. So that means 2 in 50 is 25. What can go? Whatever number that ends with 5 or 0, 5 can divide it. 5. 5 in 25. How many times will you get 5 inside 25? Is 5 times. Ended in 5. 5 again. 1. Now, how do you get the square root we are talking about? You just go, what did you use to multiply? 2 times 2 times 5 times 5. Now, square root, it's going by pair of 2. 2, 2, 2 times 5, 5, 5. 2 times 5 is 10. That is the square root of 100. That's how to get it. So until you divide until you end in 1. Then you group them in pairs of 2. And whatever you get after multiplying the independent you got from the pairs is what your result should be. Okay, let's go ahead with our fractional index law. 64 raised to power 2 over 3. So, as explained earlier, we have cube root of 64 power 2. Okay? So, in this case, you just find the cube root of 64. The same way we did square root 64. What can go? It ended in even number. So, you go with 2. 2 in 6, 3. 2 in 4, 2. 2 again, it ended in even, so you continue with 2. 2 in 3, 1 remainder 1. 2 divide 12, 6. 2 again, 8. 2 again, 4. 2 again, 2. 2 again, 1. So, we've divided it. Now, what do you do next? List out what you use, or you can just go straight. In square root, you pick them in pairs of 2, but in cube root, you pick them in pairs of 3. Square root by 2, cube root by 3, fourth root by 4. Whatever the root is, you pick it by that number. Okay, so we have 2, 2, 2. That's 1, 2 times 2, 2, 2. Another 2. That means 2 times 2 is 4. That means the cube root of 64 is 4. Because 4 times itself 3 times. 4 times 4 will give you 64. So in this case, we have 4 power 2. There is no need putting the bracket anymore. So 4 raised to power 2 means 4 times itself, which is 16. So we have 16. That's for fractional index law. Let's go to the next, which is power of power law. In power of power law, you have things like 3 raised to power 2 all cubed. That means we have a power inside and a power outside. In mathematics, Wherever you see bracket, it means times. There is no need going straight 3 raised to power 2, 9, 9 raised to power 3. You're stressing yourself. Just go straight and say 3 raised to power, multiply the powers. 2 times 3, 6. Instead of going that long way, you just go 3 raised to power 6 and you get your answer. Okay? Now, in summary, whenever you have any problem that has to do with power, just know the example that it looks like or the law it looks like and go straight, use the principles of the law to sort it out instead of breaking the powers and you have excessive numbers and you start breaking down again. It will be stressful. Go straight and multiply or divide or get your zero index or use your negative law or use your fractional index law and power of power law. Why not solve these activities? So we have 2 raised to power 5 times 2 raised to power 3. 4 raised to power 3 divided by 4 raised to power 2. What is the result of 7 raised to power 0? What is the result of 2 raised to power minus 3? 100 raised to power 1 over 2. And finally, 3 raised to power 4 all squared. Drop your answers in the comment section. Don't forget to like, share, and subscribe. Catch you in our next class.